to provide for regular payments. Okay, so the present value is going to be the PV. Okay, that's the amount you need today to invest. And then what happens to this amount is, like, just for example, say you invest $1,000. Next month you take out 100. So now you have 900 left. Okay, following month you take out 100. So negative 100, right? We subtract it. Now 800 is left. However, what happens is when these amounts are in really big numbers and it's gaining interest, it's not actually going to be 900. It's going to be 900 and something. Like, it's going to be a little bit above 900, then a little bit above 800. Okay, so over the course of the investment, you're still actually making money. Okay, R, again, is the regular payments. That's not going to change. I is going to be the exact same thing. We're going to take I and we're going to divide it by the number of compounding periods per year. Okay, and then N is the total number of compounding periods. If you look here, this is a negative. So raised to the negative N. And then it's all over I. And we're going to do it in chart style again so that we can really organize our ideas. Okay. Interest of an ordinary simple annuity. This is given by the interest is what you invested. So what you invested times the number that you invested. So that would just be the total. This would be total invested. And then PV is present value. So by subtracting those two things, we can see how much interest it actually earned. Okay, example 1, the present value of an annuity. So Peter bought a car and his monthly payments are $245. So I'm going to put the $245 right into where the R is. $245. Okay, it'll take 1 year to pay off his car. So 1 year would be 12 months. I kind of looked ahead, but this is actually going to be compounded monthly, so that's fine. His car loan is at an interest rate of 12%. So when we take 12%, we want to take the 12 divided by 100, and then we're going to get our I. So 0.12. Okay, and because it's compounded monthly, we're going to actually divide that by 12. So he's going to get 0.01 paid out 12 different times. Okay, and we already talked about 1 year. So it would be like 1 year times how many months a year? Well, it'd be 12 months. And all we're going to do is we're going to take this information and we're going to plug it in to this formula. Okay, so the question is, what's the actual cost of the car, like the actual present value? Okay, so when we talk about present value, we can also talk about loans. Okay, what the car is worth. And say you bought a car for $10,000. Well, at the end of the loan, you're not going to have paid $10,000. You're going to actually have paid more. Okay, and that's where the interest comes from. Okay, so present value equals 245, square bracket, 1 minus 1 plus the I, which is 0.01. Okay, raised to the negative 12, square bracket, and 0.01. Okay, by the way, 1 year is very quick to pay off the car. So we have 0.11255 all over 0.01. Okay, and I'm just putting these in for you so you can follow along with your calculator. Make sure that you're getting the right answer. Okay, and then the last step, I get 2757. 49. By the way, this is just an example. Okay, so the car costs, we can go the car costs 2759.49. He's actually putting 4020 in for B. How much does he actually pay? Well, he pays 4020 and he pays that 36 times. So when we multiply that, we can see that he actually paid $1447.20. But here's the thing. He paid $1447.20. The laptop only cost $1,200. So he actually paid, when we subtract those, $247.20 in interest. So we say, therefore, he paid $1447.20, of which $247.20 was interest.